In doing statistics, there are other approaches by which we can analyze our data. As we continue, this lecture on chi-square test will introduce us in another way of calculating our data, especially if we wanted to know the distribution, frequency, and relationship of specific variables we want to examine. For our points of discussion, we will explore the following. First, the chi-square test. Its definition, its nature of assumption and levels of measurement, and of course, the chi-square test formula. Next are the types, assumptions, and parameters. Here, we have three types that employs the chi-square formula, and also the assumption and parameters that we can use to determine if our data qualifies. Third, our purpose, which we provide a brief synthesis including the premise, methodology, and findings from featured resources. Computation. Lastly, the computation, which includes the sample problem and the procedure using Microsoft Excel and Jamovi software. Delving to the first part, the chi-square test. The chi-square test is used to examine the pattern derived from the observation to determine the frequency of certain categorical combination based on its amount of occurrence. This is used to determine if there is a significant relationship between the two categorical variables. It seeks the association between variables that enables analysis of the relationship between the observed set of data and the theoretical sets of data to test the hypothesis. To supplement, the contingency table provides a template where the data can be managed and organized to draw inputs and variables, facilitating the testing procedure. Chi-square test is a kind of non-parametric test which are not dependent on assumption based on the parameters and certain attributes of the population distribution. Chi-square test can treat nominal or ordinal data and is functional in operating with categorical variables. Simply, it means that it will not require one to identify the distribution of data, might it be normal, binomial, or exponential. The chi-square formula as follows. The chi-square expressed as x squared equals to the summation of parentheses O minus E squared over E, where O is the observed values while E is the expected values. Next are the types, assumptions, and parameters. The chi-square test constitutes three kinds of approaches depending on the conditions and variables present. Test of independence for determining the relationship between two categorical variables. This is used to determine if those two variables are independent or not. The primary outcome it often produces displays the relationship of variables if they are independent or dependent, used to test whether two categorical variables are related to each other. The goodness of fit for comparisons of single categorical variables of three or more independent samples. This one is used to determine the fitness of a particular unknown data into a known distribution. This is also utilized to know the uniformity of population, if it is normal, or whether it is synonymous with other population with known distribution. Oftentimes, we have our known distribution, which is the observed values, while we test if it fits with the unknown data, usually the expected value. The test of homogeneity for identifying if there are shared values between two categorical variables. This test can draw conclusions if the unknown distribution of variables is shared the same by the given population. It mainly centers on the homogeneous or similar characteristics of two populations depending on the variables. Now, to identify what to use, the assumptions and parameters serves to guide whether a particular problem or situation qualify to either of the three. For the test of independence, we have the assumption number 1. The two variables identified must be at the ordinal or nominal level of measurement. This is shared across the other test. Assumption number 2, the two variable identified must comprise with two or more categorical independent group. Since we are making comparisons or assessing the relationship in test of independence, we need to have a distinctive traits that falls in the same category but has a different characteristics such as gender, specifically the male and female. The goodness of fit. For the first assumption, there must be one categorical variable measurable as a nominal, ordinal, or dichotomous variable. Second assumption would be that the independence of observation is essential. It means that there must be an absence of relationship between any of the variables. Our third assumption is that the identified groups within the categorical variable must stand mutually exclusive. It must share similar features with distinctive qualities. Now, for the test of homogeneity. For our first assumption, the two variables identified must be at an ordinal or nominal level of measurement. Our second assumption is that the two variables identified must comprise with two or more categorical independent groups. This test can draw conclusions if the unknown distribution of variables is shared the same by the given population. It mainly centers on the homogeneous or similar characteristics of two populations depending on the variables. And for our key assumption, the expected frequencies must have a value lower than 5 in each group under the categorical variable. Otherwise, it will be deemed unqualified for the test. When do we use the chi-square test? As discussed earlier, chi-square test generally dives through the relationship between group and variables. It also considers whether certain outcome is brought by chance or merely was induced due to specific association. For our featured resources, here are some studies that employed chi-square test to derive conclusions based on the outcome of testing results.
The first article titled Comparison of the Learning Outcomes in Online and In-Class Environments in the Divisibility Lessons. The premise of this study sought to evaluate the effects of learning environment to the students' achievement in the divisibility lessons. This study used the statistical method, which is the chi-square test of independence. It is the statistical test employed to identify the relationship of learning environment to students' performance on divisibility. And the test aims to determine whether there is a difference in the learning acquisition on divisibility between in-class environment and in online environment. So based on the result, it is revealed that the students only acquired the basic knowledge and understanding of divisibility during the online session. Another featured resources titled Do High Ability Learners Enjoy Learning Alone or in Groups? It depends. The purpose of this study is to comprehend the preferences of boys and girls who are high-ability learners for working in groups or alone, including the particular attention to the interpersonal relationship and processing implication of the selected task. So what was the statistical method used in this study? This study was to discover more about students' performance, whether when and how highly capable students choose to work alone or with others. So this study used the chi-square test of homogeneity because this study employed to determine whether the two populations come from the same distribution, and based on the result, a large number of students said they preferred working alone and sometimes they enjoyed studying with others. For instance, when given the opportunity to choose their group or work with people who learn at their pace, so the two populations determined have the same distribution. The third featured resources with the title of Performance-Based Assessment in Virtual versus Non-Virtual Classes, Impacts on Academic Resilience, Motivation, Teacher Support, and Personal Best Goals. The study sought to address the gap by examining the situations in which performance-based assessment is more useful and to determine the impact of resilience, motivation, teacher support, and personal best goals. The study uses a set of established instruments to measure and assess the different experiences and performances of participants in different learning environments. Since there is an association, the test used was test of independence. On this study, the chi-square test was utilized to examine relationship among variables. And according to the study, it revealed that online classes significantly improve students' resilience and motivation compared to traditional physical classrooms. So means online learning methods result in better performance by online learners. These researchers sought to collect data focusing on the relationship, connection, or attributes between variables using the chi-square test. The study used the method to determine if there is a significant association between categorical variables or to decide whether a population distribution fits to the given distribution. The aim of this featured resource is to give valuable insights into the relationship within the data. This statistical test is often applied in study or research to analyze data about the relationship between different factors by collecting detailed descriptions or the variables under the exploration, so the researchers can better understand the nature of the relationship and the significance of the findings.
Now, let us proceed to the computation where there will be a provided problems that we will assess. For this, we will be using the Microsoft Excel application and Jamovi, a statistical tool. Learning how to navigate these tools will enable us to process data more efficiently. Let us examine different problems using the chi-square test of independence. For our test of independence problem number 1, Miss Riley, a music instructor, wants to find out if music preference and gender is independent. Her interest was to find out whether a person's gender has an influence to their music taste. Provided below is the hypothesis and significance level she used. She also conducted and organized a survey for this investigation. For our hypothesis, we have the null hypothesis: gender and music taste or music preference are independent. For our alternative hypothesis, we have gender and music preference are not independent, meaning they have some sort of relationship to one another. Our significance level is 5% or 0.05. In processing our data, we can utilize Microsoft Excel to organize and compute statistics. This is often done through typing specific functions. Assuming that what we've got is a document containing responses from the survey, of course, we will not count each values one by one. We can, however, apply countifs function that works by identifying the value based on the criteria that we have set for particular range. In this manner, we can determine the descriptive and the sum of population that we have. Simply type the function, selecting the cells or range by holding the Control tab button while selecting all the datas across the bottom. We can copy the function and change the criteria to make it more efficient. This will give us an insight on the initial distribution of responses. Now, the first thing we want to do is to create our contingency table. Using the similar process, copy or type the countifs function. For the first criteria, select the column that contains the group. This is followed by a comma and the quotation mark that contains the criteria we wanted to identify. Since we are dealing with two criteria, add another comma after the first criteria and select the variables or the second column. Put a comma followed by a quotation mark, this time containing the categories, to identify the variable. This will give us a specific values based on the groups and variables that we have categorized in the criteria. Copy and repeat this process on the other column until we fill the values based on the categories that we have for the test. In this example, we have 4 music genres, which means 4 columns to fill. Remember to change the criteria per cell depending on the category above that serves as the criteria. Upon completing the process, make sure to sum the value of each rows and columns. We will be utilizing these values in getting our expected values. It is important that we yield equal amount of distribution similar to the total number of population. So if it is 162, the distribution must also have a summation of 162. Make sure to put an outline to organize your table. Now, duplicate the first table by selecting all the cells that composes our table. Make sure to remove the values since we will be putting here our expected values. In computing the Excel values, we need to get the total value of the first row, multiplied to the first column, and divided by the total number of population. In this instance, we have 72 times 51. divided by 162. This should give us the value of 22.7. As we repeat the process, for the second cell or category, select the total value within the same row, which is 72, multiplied, but this time on the total value of the second column, which is 43, divided by 162, which will result to 19.11. As you repeat the process, take note to align the groups and category and use the total value of a specific row and column. This means that once you are done with the boys, you may proceed to the second row, going through the same process of identifying the total values per column or category. Overall, this should be the product. Once you have the expected values, we can now proceed to the chi-square test. Remember, our chi-square test formula is x squared equals to the sum of parentheses O minus E squared over E, where O is the observed value, while E is the expected value. To do this, first, type an open parenthesis and select the first cell for observed values in the first group and category. Put a minus followed by the expected values. Enclose with the parenthesis and type a caret or this upward symbol. Then type 2 as this will represent the squared function. Type slash as a divide symbol and select again the same expected value. Upon entering, it should give you a result. In repeating the process, again, the first group, but this time, select the second value within a category of both observed and expected values. This means that we will select the cell containing 18 for observed and 19.11 for the expected. Type the proper formula and enter to get the result. After getting all the result, select a cell and type equal sum and hold the control button to then select all the cells containing the outcomes. This should yield the total summation of those values which will represent the chi-square result. What do we do then? First, type your chi-square result. Second, identify the degrees of freedom which follows the formula of row minus 1 multiplied by the column minus 1. In this case, we have 2 minus 1 equals to 1 and 4 minus 1 equals to 3. Therefore, we will have 3 times 1 equals 3. Normally, we can compare our chi-square already to know if there is an association, but let us get our p-value since it will dictate the probability of getting our chi-square result. This acts as a reinforcement that supports the hypothesis. Using the formula equals chi-square distribution of right-tailed, we can select the cell containing the chi-square result and the degree of freedom to calculate our p-value. In order to use this, we need to go back with our significance level, which is again 5%. Using the chi-square distribution table, use the degrees of freedom in identifying the row, while the significance level to determine the exact critical value based on the columns. By looking at the degrees of freedoms, which is 3, with a significance level of 5%, our critical value is 7.81. How do we make conclusion? If chi-square is less than or less extreme than the critical value, then we will not reject the hypothesis. If the chi-square is greater than or more extreme than the critical value, then reject the null hypothesis. If our chi-square is greater than or more extreme than the critical value, we will reject the null hypothesis. Since our chi-square is less than the critical value, then we will not reject the null. Now, if our p-value is less than the significance level or 5%, it is statistically significant, which means we will reject the null hypothesis. If the p-value is greater than 5%, then it is not statistically significant, which then result in accepting the null. Since our p-value is 0.91, and is greater than 0.50, then we will not reject the null. P-values enables us to know whether the hypothesis is brought about by chance. If the p-value is less than, it means that it is highly unlikely to have such chance. If it is greater than, then we can somehow derive that it is or affected. Therefore, we can have a conclusion that gender and preference is independent. The p-value reinforces that there is no sufficient basis to reject the null, suggesting that they may not be the same. And now, in doing the chi-square test in Jamovi software. First, launch the Jamovi. Afterwards, tap this layered icon, then find and click Option. You need to locate and select the document. Jamovi will process the document for a short while. Once it is loaded, you will notice that there are no numerical values yet, since this simulation is brought by the assumption on how we will process the data based on the initial survey outcome. Now, make sure to identify the groups and the categorical variables. Open the descriptive option on the menu. You will notice that there are two needed data, which are the variables and the split by. Both of those needs the data from which the sample will be distributed. Load the first column in the variables. This will give you the quantity of sample or the sum. While if you added a data in the split by, it projects a distribution. Next, click and open this option for statistics and remove other values that we will not be using. Click the frequency table to generate a visualization of how the population is distributed. Note that this is not essential, but if your study deems it necessary, you can automatically generate through this option in Jamovi for the computation. Now, to apply the formula, click the frequencies and look for the contingency table. Look another for the independent samples with the label chi-square test of association. Do not be confused as this term is interchanged with chi-square test of independent. Both refers to the same type using the same formula and process. This will lead you with these features where you will need to insert the values. Here I identify the groups and the categorical variables. Put the groups or the male or female on the rows while place the categorical variables, the music preference, on the columns. It will process the data and will provide an immediate overall statistical computation once it is done. You can see below a table containing the sum of the population, the chi-square value, the degree of freedom, and of course, the computed p-value. To expound, since these are only the observed values, we can click the cell setting to toggle the expected values. Remember, we can get our expected variables through Excel or manually by computing the sum of the row multiplied to the sum of the column divided by the total sample or population. Further, on the plots below, we can once again generate a bar plot with distributed values. Yet again, you may just do this if essential. On the uppermost right, there is 3 vertical dots that once clicked, it will show additional features such as the option to change the number format and the p-value format where we can select to consider additional decimal points and significant figures. It may range from 3, 5, and even 16. And this is how you use Jamovi in processing chi-square test of independence. Now, going back, our significance level is 5% or 0.05. The values under our decision rule are chi-square result equals to 0.53, our degrees of freedom equals to 3. Using our significance level and degrees of freedom, we can have the critical value of 7.81. Our p-value is equals to 0.91 or 0.91118. For our conclusion, we can conclude that our chi-square is less than the critical value, which means we will accept the null hypothesis. Inversely, our p-value, 0.91, is greater than the significance level, which then we will accept the null hypothesis. This means that gender and music taste are independent and does not have any effects on one another.
So for our test of independence problem number 2, The local coffee shop conducted a survey among girls and boys on which coffee flavor the students prefer when they are doing research. Provided below is the hypothesis and significance level that we use. For the hypothesis, we have null hypothesis, which is gender and preferred flavor are independent, meaning they are not related. Second, alternative hypothesis, gender and preferred flavors are not independent. The significance level that we use to this problem is 5% or 0.05. So, let us examine the problems using the chi-square test of independence. In processing our data, we can utilize Microsoft Excel to organize and compute statistics. This is often done through typing specific functions. Assuming that we've got a document containing all responses from the survey, of course, we cannot count each values one by one. So, what we are going to do is calculate our descriptive, and this can also measure our population. The next thing that we need to do is applying the countifs functions that works by identifying the value based on the selected criteria. So, we need to simply type the function selecting the cells or range by holding the Control tab while selecting all the data across the bottom. After we copy all the data through the bottom, let's check our countifs and click the given groups or population, which is the boy, and we have 200 boys. And we need to do the same thing. So let's change the boys and type girls, and we have 300 girls. Using this, we can determine the descriptive and the sum of population that we have efficiently. So we should type equal sum to get the total population of boys and girls. Now we have 500 total respondents, so since we have our descriptive, just hold the table and bold the border to better understand the table. The next thing that we need to do is create our contingency table. So, to our contingency table, we need to input the flavor such as macchiato, espresso, and cappuccino. So since we already input our flavors, let's type the student ID and using the similar process, copy or type the countifs function for the first criteria. Select the column that contains the group. This is followed by a comma and a quotation mark that contains the criteria we wanted to identify. So now, let's hold the criteria because like what I said, we can copy the function and change the criteria to make it more efficient. And type the flavor, which is the macchiato. And after that, proceed to the student's ID. Let's select the student's ID bottom down. And after selecting all of the student ID, let's type the boys. Now we get 55 boys for macchiato. We can copy the function and change the criteria into espresso to make it more efficient. So we got 79 for espresso. Change the criteria again into the cappuccino. We got 66 for cappuccino. Like what I've said, we can copy the function and change the criteria to make it more efficient. And for the girls, we have 116 for the macchiato and 125 for the espresso. And lastly, for our cappuccino, we have 59. So now we will identify the total of this. Again, we can use equal sum. We can type equal sum and copy all of the values. Now we got 200 and for the girls, we got 300. The next thing that we need to do is let's add the values of each flavor. So for macchiato, we have 171. And for the espresso, we have 204. And for the cappuccino, we have 125. So as you can see, the total of the column and the total of the row are similar. We have 500 total, so that is our observed value. So let's create our expected table. Copy the table and remove all the values from the observed table to get our expected value. we should follow the formula. Row multiplied to the column divided by the totality. Example, 200 multiplied to the 171 divided by 500. So we get 68.4, and we will do the same to the other values. So now we are complete to the expected table. So now we already got our expected table. We can see here that there's no difference to the totality of the row and to the column. So the next step we will take is to identify our chi-square. First, let's select the symbol or summation, and the formula is observed minus expected squared divided by expected. So let's follow this formula to get our chi-squared. Observed minus expected squared divided by expected. So our observed is 55 minus 68.4 squared divided by 68.4 again is equal to 6.625146199, and same process to the other values. And after the computations, we will add this together. Equal sum and paste it to the top. And after pasting it to the top, now we will add this together. Let's type equal sum and the values. And now we got our chi-squared value, the 13.05. After we get our chi-squared value, now let's get our degrees of freedom with the formula of close open parentheses. Let's type the R minus 1 and C minus 1. R means row, C means column. And for our R or for our row, we have 2 minus 1, and for the column we have 3 minus 1. So our degree of freedom is 2. So our degree of freedom is 2. Let's check our alpha or our significance level. Let's click the symbol and type 5% or 0.05. And our critical value is 5.99 based on the table. So let's proceed to our p-value. Our p-value is equals to chi, then copy the chi-squared, and after that, follow the degree of freedom, which is the 2. And our p-value is 0.0014668, and so on. So our chi-squared value is 13.5, means it is greater than to the critical value 5.99, while our p-value is 0.00146668 is less than to the significance level 0.05, we will reject the null hypothesis. Again, let's add border to better understand the table.
So, the first thing that we have to do is open our Jamovi. And we have to import the documents, and the documents of each data need to be separated. So let's start with the test of independence. So here are the list of datas. The first thing that we have to do is click the exploration and then click the descriptive to get the insights of the population. And our variable is student ID and split by the flavor to check the distribution. So now we have a population of 500 when it comes to the student who answered. So we can see here the other things. We have to remove this because we are not going to check them. And let us include the bar plot also for us to identify how it look like visually.
So, as we can see in the frequency chart, we can see how it was distributed, such as the percentage of those students who respond.
We can also see the total number of cappuccino. And the next step is select frequency and select independent samples. So we can see here our contingency table. Everything will be automatic once we have transferred our data. So we will be adding the student ID or our variable for the row, and for the columns is our categories, which is our flavor. So here's the data, and as I can see, it is accurate. We have 300 girl student and 200 boys with a total of 500. We can also check the expected counts. We should click cells and click the expected counts. And as I can see, it is accurate to our manual computations. So to get our expected value, we should multiply the frequency columns to the frequency rows and then divide to the total number of the expected frequency. So let's check our generated plot. This shows us the preference between boys and girls when it comes to their preferred drinks whenever they do research. And now, additional, there's an option of the three dots where we can expand the format when it comes to decimal points. We are using four variables to ensure that the data refines because it offers us the more comprehensive views.
Since our significance level is 5% or 0.05, while the values under our decision rule are x squared or chi-squared is equal to 13.5 and the degree of freedom is 2, using our significance level and degree of freedom, we can get our critical value, which is 5.99, and our p-value is 0.001466. So for our conclusion, we can conclude that our chi-square is greater than to our critical value and our significance level is greater than to the p-square. Now, we will reject the null hypothesis. Means our gender and preferred flavor are not independent, meaning there is no relationship between the categorical variables. Let us analyze the different problems by utilizing the chi-square goodness of fit method.
For our goodness of fit, problem number 1, Dr. Ronnie wants to know how many students still visit the public library for potential renovation. So he asked the security of the library, Mr. Brian, on the amount of student visitors he can estimate from the month of January to May. Now, our hypothesis here is that the null hypothesis states the security guard's distribution claim is correct, meaning his estimation is fits with the population that we can derive based on our observation. Second is that the alternative hypothesis stating that the security guard's distribution claim is incorrect, meaning there is no credibility nor grounded basis for that estimation. Now, the significance level utilized for this problem is 5% or 0.05. Now, let us proceed in assessing the goodness of fit. For the goodness of fit, since Sir Ronnie is quite hesitant of Sir Bryce's idea, he went to get a copy of logbook records from the head librarian. Based on the document, this is what it contains. Now, we are going to test only the month as a variable whether it fits the theoretical assumption of Sir Bryce on the amount of student visitor. First, construct a descriptive table that will contain the initial data and population that we have. Now, we will construct an observed value table. Once you are done with the observed values, add or type the expected values given based on the assumption. One key difference after typing those values below the observed or actual data is that we will get the expected observed value or the combination of both. This can be done through the formula of E or the expected percentage multiplied by the total population. In manual process, just add a 0 followed by a decimal point to compute, which makes 25% into 0.25%. Now, type equals, then parenthesis. Afterwards, select the cell containing the total number of population, then enclose with parenthesis. Repeat the process until you complete the table. Once you are done, we may now proceed in getting the chi-square value. Again, the formula is chi-squared equals to the sum of parentheses O minus E squared over E, where O is the observed value, while E is the expected value. To do this, first, type an open parenthesis and select the first cell for observed values in the first group and category. Put a minus sign, followed by the expected observed value, not the percentage, then enclose with the parenthesis and type a caret, or this upward symbol, then type 2, as this will represent the squared function. Type slash as a divide symbol, and select again the same expected observed value. Upon entering, it should give you a result. In repeating the process, again, select the second column and transpose the observed values and the expected observed values within the formula and continue. Once you have acquired all the result, type equals sum, parenthesis, then hold the Control tab to select all the cells containing the result, then enclose it with parenthesis. After entering, you will receive your chi-square value. What do we do then? First, type your chi-square result. Second, identify the degrees of freedom, which follows the formula of column minus 1, since it is what we only have here. In this case, we have 5 minus 1 equals to 4. In order to use this, we need to go back with our significance level, which is 5% or 0.05. Using the chi-square distribution table, use the degrees of freedom in identifying the row, while the significant level to determine the exact critical value based on the column. By looking at the degrees of freedom 4 with a significance level of 5, our critical value is 9.49. We can now process whether our chi-square value is relative to determine its fitness to the theoretical data. But first again, let us get our p-value since it will dictate the probability of getting our chi-square result. This acts as a reinforcement that supports the hypothesis. Using the formula equals chi-square distribution of right-tailed, we can select the cell containing the chi-square result and the degree of freedom to calculate our p-value. How do we make conclusion? If chi-square result is less than the critical value, we will not reject the null hypothesis. If the chi-square is greater than the critical value, then we will reject the null hypothesis. Since our chi-square is greater than the critical value, then we will reject the null. Now, if our p-value is less than the significance level or 5%, it is statistically significant, which means we will reject the null hypothesis. If the p-value is greater than 5%, then it is not statistically significant, which then result in accepting the null. Since our p-value is 0.00026 and is less than or 0.05, then we will reject the null. P-value enables us to know whether the hypothesis is brought about by chance. If the p-value is less than that, it means that it is highly unlikely to have such chance. If it is greater than, then we can somehow derive that it is motivated or affected. Therefore, we can have a conclusion that Sir Bryce's account does not fit the actual population. It is not reliable, and we may consider appealing to other credible figures as well. For the goodness of fit, as usual, first, launch the Jamovie. Afterwards, tap this layered icon, then find and click the Open option. You need to locate and select the document. Jamovie will process the document for a short while. Once it is loaded, you will notice that there are no numerical values yet, since this simulation is brought by the assumption on how we will process the data based on the situation where this is the logbook of the library containing the data of student visitors. Now, make sure to identify the variable since we are looking for the amount of student visitors each month. So we will select the column that contains the months. Open the descriptive option on the menu. You will notice that there are two needed data, which are the variables and the split by, which requires us to submit or fill the data from which the sample will be distributed. Load the first column in the variables. This will give you the quantity of sample or the sum. Next, click and open this option for statistics and remove other values that we will not be using. Click the frequency table to generate a visualization of how the population is distributed based on these months. Note that this is not essential, but if your study deems it necessary, again, you can automatically generate through this option in Jamovi. Now, to apply the formula, click the frequencies and look for the one sample proportion test. Under this is the N outcomes with the label chi-square test of goodness of fit. This will lead you to these features where you will need to insert the values. Now, make sure that you have identified your variable. Note that this is the main consideration for Jamovi to calculate the result. It will process the data and will immediately provide an overall statistical computation. Notice that the table has this proportion value, which is evenly distributed, and an option to show the expected values under the observed values. Remember, in the goodness of fit, we are trying to determine whether a particular set of values applies to the theoretical or the expected assumption. Now, the source of expected assumption here is Mr. Bry or the security guard. So we will need to modify this distribution since it just automatically distributed the percentage equally in the population. To do that, select the expected proportion and you just have to type the given expected values to you. Your basis or the variables that we will be using are the one that we are trying to work on. So Jamovi will transmute this into percentage. So here we are basing on the assumption of expected values with 15% for January, 45% for February, 20% for March, 10% on April, and 10% on May. Based on Mr. Bry, this yields to a 100% representation. Upon encoding those values, you will then get a much more precise and specific goodness of fit result. You can see below a table containing the sum of the population, the chi-square value, the degree of freedom, and of course, the computed p-value. Further, remember we can get our expected values through Excel or manually by computing each percentage of the expected values multiplied to the sum of the population. You can add 0 point or 0 decimal point on the first part of the value of a particular percentage to calculate it. And this is how you can process goodness of fit, chi-square statistic, in Jamovi. Now, returning to the presentation, our significance level is again at 5% or 0.05. The values under our decision rules are chi-square equals to 26.39 with the degrees of freedom equals to 4. Now, our critical value is 9.59, which is based on our degrees of freedom and significance level. Our p-value is 0.000026. Now, let's have our conclusion. So we can say here that our chi-square result is greater than the critical value, which means we will reject the null hypothesis. Now, for our p-value, we can say that our p-value is less than the 5% or the significance level, which means we will reject the null hypothesis. This means that we will be accepting the premise of our alternative hypothesis, which states that the security guard's distribution claim is incorrect.
For our goodness of fit problem number 2, the manufacturer of the pen is interested in finding out how many student customers on a daily basis for a week. So one of the staff members, have Abby, was asked the number of student customers every day for a week. So our hypothesis is the staff distribution claim is correct. Second, the staff distribution claim is incorrect. And the significance level that we use here is 5% or 0.05. So open our file because let's examine the problem using the chi-square goodness of fit. Just like what we did, we will use Microsoft again. So assuming that we've got a document containing all responses from the survey, of course, we will not count this one by one. So, what we are going to do is to calculate our descriptive and the day. Now, let's type our day
Monday, Tuesday, Wednesday, Thursday, and the Friday, and their values. For the Monday, we have 28. For Tuesday, we have 35. For Wednesday, we have 40. And for Thursday, we have 58. And lastly, for Friday, we have 39. Using this, we can determine the descriptive and the sum of the population that we have efficiently. Type equal sum to get the total population. And now, we have total respondents. We have 200 total respondents. So, since we have our descriptive, just hold the table and bold the border again to better understand the table. Next thing that we need to do is create our contingency table. So, input the day, which are the Monday, Tuesday, Wednesday, Thursday, Friday. And let's write our observed value. And type observe, and let's input the values. For Monday, we have 28, Tuesday, 35, Wednesday, 40, and for Thursday, 58, and Friday, 39. And sum this all together to get our total. So now, type equal sum and get the total values, which is the total is 200 total values. So since we already transfer our observed values, let's input our expected percentage. So type expected and write the expected values for each day. So for Monday, we have 25%. For Tuesday, we have 20%. So for Wednesday, we have 25%. And for Thursday, we have 15%. And lastly, for Friday, we have 15%. And for the total, let's sum all of this. So, equal sum. So, for the total, let's sum all of this. So, we've got 100%. So, again, add border to better comprehend the table. Since we already got our observed and expected values, the next thing we need to do is to get our expected observation values. So, to get the expected observation values, always remember the formula for computation. E or expected times summation observation, and the result will be the expected observation. Like for example, for our Monday, we have 25% or 0.25, and the total value of observed is 200. Now, we can multiply it together and we have 50 value. Same goes to the others. So for the Thursday, as we can see, we have 15% or 0.15. And let's multiply it to the total of observation, which is 200. So we have 30. And for the Friday, we have 15%. And let's multiply it to the 200 with the total. So we have 30. So let's sum all of this. So we got 200 total expected observation. And always put border to clearly understand. So now we already compute our expected observation. The next thing that we are going to do is we will now get our chi-square. And for our chi-square formula is x squared equals summation and observation minus expected squared divided expected. So what we are going to do is our observation or observed value is 28. So minus it to the expected observation, which is the 50, and squared divided by 50. So we've got 9.68. And same to the Tuesday, we have 35 minus it to the 40 and divide it to the 40 again, we got 0.625. And for the Wednesday, we've got 40 minus 50 and squared divided 50, and we got 2. So for the Thursday, we've got 58 and minus it to the 30 squared divided 30, and the result is 26.13333, so on. And for the Friday, we've got 39 minus to the 30 squared divided to the 30, and we've got 2.7. So after computing all of these, all we need to do is write chi-squared and sum all of the value that we have. So we have 41.13 or 41.14. So that's our chi-squared value. So let's proceed to get our degree of freedom or DF. So the formula of degrees of freedom is close open parenthesis k minus 1 or row minus 1 and column minus 1 or C minus 1. So we have 5 minus 1 is equals to 4. So now our degrees of freedom is 4. And for our alpha, we have 0.05. And based on the table, the critical value of 0.05 and the degrees of freedom of 4 is 9.49. So let's proceed to our p-value. Equals chi and the chi-squared values and our degree of freedom 4. The result is 2.51 and so on. So now, since our chi-squared is 41.14 is greater than to our critical value 9.49, we will reject it. Same to our p-value. Since our p-value is less than to our alpha, we will reject it too. And again, don't forget to put the border to better understand and comprehend the table. To continue, we will be doing the same process like what we did during the first or during the test of independence. Now, let us find our document for the goodness of it. Again, let's have the descriptive. The next is let's have our variables. So now we have 200 respondents, and regarding this, we will be removing these things because we won't be using this. So let us add our frequency table. We can see the distribution of how they have respondents. And now that we have our statistic, let's create the bar plot to visualize the distribution. So let us proceed to our frequencies, which we will select the goodness of fit under the sample proportion. And again, let's have our variables. So initially, these are the value that we got, but this is actually inaccurate since we are yet to lay our expected values based on the inquiry. So what we will do next is have our expected values. As you can notice, all of these are distributed equally, but we need to input our expected proportion or percentage to check whether there is a correlation. All we need to do is type our expected percentage to the expected proportion. Now, first, the Monday, we have 25%. The next is Tuesday with a percentage of 20 and Wednesday 25, while in Thursday 15 and Friday 15% with a total of 100%. So now to calculate that, what we need to do is observe multiplied by the expected percentage with the squared and divide it to the expected percentage again. So we will get the test of goodness of fit. So according to my manual computation and to this Jamovi, the result is accurate. As you can see, we have the same values. My chi-square is 41.14. And my degree of freedom is 4, while my phi value is 0.0001. As you can see, we have the same values. And I can see the similar values or same values as the one that I got in Excel.
Now, the significance level that we use is 5% or 0.05. The values under our decision rule is x squared equals to 41.13 with the degrees of freedom equals to 4. Again, using the significance level and degree of freedom, we can get our critical value with the result of 9.49, while the p-value is 0.001 or 0.0001. Now, let's talk about our conclusion. We can conclude that our chi-square is greater than to our critical value and our significance level is greater than to our p-squared. Now, we will reject the null hypothesis. This means the staff distribution claim doesn't fit to the given distribution. It means it is incorrect. Let's determine the problem if the two populations come from the same distribution using the chi-square test of homogeneity.
Now, for the test of homogeneity, problem number 1. For the upcoming school year, Dr. Cordova, the president of Philippine Normal University, wanted to know if the students from public and private schools share the same preference of learning modality. Suppose that the sample size of upcoming students from the public schools are 70, while those from private schools are 30. What result Dr. Cordova will get? For the hypothesis, our null hypothesis states that there is a similarity between the preference on the learning modality of students from both public and private schools. For our alternative hypothesis, it states that there is a difference, meaning no similarities, between the preference on the learning modality of students from both public and private schools. Our significance level used for this application was 5% or 0.05. Let us process further in gray. Now, in computing the test of homogeneity, we are looking whether there are shared variables or characteristics across the groups. Assuming that we have a copy of the survey result from the upcoming students, let us again process our descriptive data for initial insight. Use the equals COUNTIF function, followed by a parenthesis, then hold the Control tab and select the groups all the way to the bottom. Put a comma, then a quotation mark containing your criteria, which we will be typing public school, to know the amount of public school student population that have responded. Do the same process by copying and pasting the function and change the criteria of public school into private school. After this, we may now proceed in creating the contingency table. A keynote here is that the test of homogeneity follows the same process as the test of independence. First, let us identify our observed values using the COUNTIFs function. For the first criteria, select the column that contains the group. This is followed by a comma and the quotation mark that contains the criteria we wanted to identify. Since we are dealing with two criteria, public or private school and their preferred modality, add another comma after the first criteria and select the variables or the second column, which is the preferred modality, then put a comma followed by a quotation mark, this time containing the categories to identify the variable. This will give us a specific values based on groups and variables that we have categorized in the criteria. Copy and repeat this process on the other column until we fill the values based on the categories that we have for this test. In this example, we have 3 types of modalities, which means 3 columns to fill. Remember to change the criteria per cells depending on the category above that serves as the criteria. Upon completing this process, make sure to sum the value of each rows and columns. We will be utilizing these values later in getting our expected values. It is important that we yield equal amount of distribution similar to the total number of population. So if it is 100, the distribution must also have a summation of 100. Make sure to put an outline to organize your table. Duplicate the first table by selecting the cells that composes our table. Make sure to remove the values since we will be putting here our expected values. In computing our expected values, we need to get the total value of the first row multiplied in the first column and divided by the total number of population. In this instance, we have 25 times 70 divided by 100. This should give us the value of 17.5. As you repeat the process, take note to align the groups and category and use the total value of a specific row and column. This means that once you are done with the public school, you may proceed to the second row. Going through the same process of identifying the total values per column or category, overall, this should be the product. Once you have the expected values, we can now proceed to the chi-square test. Remember, our chi-square test formula is chi-square equals to the sum of parentheses O minus E squared over E, where O is the observed values while E is the expected value. To do this, first, type an open parenthesis and select the first cell for observed values in the first group and category. Put a minus sign followed by the expected value. Enclose with the parenthesis and type a caret or this upward symbol, then type number 2 or 2, as this will represent the squared function. Type slash as a divide symbol and select again the same expected value. Upon entering, it should give you a result. In repeating the process, again identify the first group, but this time, select the second value within a category of both observed and expected values. Type the proper formula and enter to get the result. After getting all the result, select the cell and type equals sum and hold the control button and select all the cell containing the outcomes. This should yield the total summation of those values, which will represent the chi-square test result. What do we do then? First, type your chi-square result. Second, identify the degrees of freedom, which follows the formula of row minus 1 multiplied by the column minus 1. In this case, we have 2 minus 1 equals 1 and 3 minus 1 equals 2. Therefore, we will have 2 times 1 equals to 2. That will be our degrees of freedom. In order to use this, we need to go back with our significance level, which is 5%. Using the chi-square distribution table, use the degrees of freedom in identifying the row, while the significance level to determine the exact critical value based on the column. By looking at the degrees of freedom, with a significance level of 5% or 0.05, our critical value is 5.99. Normally, we can compare our chi-square already to know if there is an association, but let's get our p-value, since it will dictate the probability of getting our chi-square result. This acts as a reinforcement that supports the hypothesis. Using the formula equals chi-square distribution of right-tailed, we can select the cell containing the chi-square result and the degrees of freedom to calculate our p-value. How do we make conclusion? If chi-square is less than the critical value, then we will not reject the null hypothesis. If it is greater than the critical value, then we will reject the hypothesis. Since our chi-square is greater than the critical value, then we will reject the null hypothesis. Now, for our p-value. If our p-value is less than the significance level or 5%, it is statistically significant, which means we will reject the null hypothesis. If the p-value is greater than 5%, then it is not statistically significant, which then result in accepting the null. Since our p-value is 0.000789, and is less than 0.05, then we will reject the null. P-value enables us to know whether the hypothesis is brought about by chance. If the p-value is less than that, it means that it is highly unlikely to have such chance. If it is greater than, then we can somehow derive that it is motivated or affected. Therefore, we can have a conclusion that private and public schools has a varying preference of modality. The p-value reinforces that there is no sufficient basis to reject the null hypothesis, suggesting that they may not be the same. And now, in doing the chi-square test in Jamovi software, launch the Jamovi. Afterwards, tap this layered icon, then find and click the Open option. You need to locate and select the current document. Jamovi will process the document for a short while. Once it is loaded, you will notice that there are no numerical values yet, since this simulation is brought by the assumption on how we will process the data based on the provided copy of Dr. Cordova. Now, make sure to identify the groups and categorical variables. You will notice that there are two needed datas, which are the variables, and the split by, which needs the data from where or which the sample will be distributed. Load the first column, or the public and private school, in the variables. This will give you the quantity of sample or the sum. While if you added the data of preferred modalities in the split by, it will project a distribution on that population. Open this option for statistics and remove other values that we will not be using. For the computation, now to apply the formula, the chi-square test of homogeneity, it follows the same procedure as the test of independence. So click the frequencies and look for the contingency table, independent sample with the label chi-square test of association. Do not be confused, since the test of homogeneity and the test of independence can function under the same process, but they do have different means of interpretation and amount of variables that can be processed. This will lead you with these features where you will need to insert the values. Here, I identified groups and categorical variables. Put the groups or the public or private schools on the row, while place the categorical variables, the preferred modalities, on the column. It will process the data and will immediately provide an overall statistical computation. You can see below a table containing the sum of the population, the chi-square value, the degree of freedom, and of course, the computed p-value. And to express this further, since these are only the observed values, again we can click the cell setting to toggle the expected variables. Remember, we can get our expected variables through Excel or manually by computing the sum of the row multiplied to the sum of the column divided by the total sample of population for each cells. Further, on the plots below, we can once again generate a bar plot with distributed values. Yet again, you may just do this if essential. On the uppermost right, there is these three vertical dots that once clicked, it will show additional features such as the option to change the number format and the p-value format, where we can select to consider additional decimal point and significant figures. It may range from 3, 5, and even 16. And this is how you use Jamovi in processing chi-square test of homogeneity. Going back to our presentation, the significance level is again at 5% or 0.05. The values we have computed under the decision rules are chi-square result, which yields 14.285 or 14.29, and the degrees of freedom equals to 2. Our critical value is 5.99, which is based on our significance level and degrees of freedom. Our p-value, on the other hand, is 0.000789. Now, for our conclusion, we can say that our chi-square result is greater than the critical value, which means we will reject the null hypothesis. Our p-value on the other side is 0.000789, which is less than 0.05, which means we will reject the null hypothesis. And for that, our statement for the alternative is the one that we will be accepting, which means that there is a difference between the preference on the learning modality of students from both public and private school.
For our test of homogeneity problem number 2, the scenario is the faculty advisor examining the different students from freshman to sophomore based on their preferred study methods, such as self-study, group study, or tutoring. For the hypothesis, first, there is a similarity between the study method of the students from both freshman and sophomore. Second, the alternative hypothesis. There is a difference between the study method of the students from both freshman and sophomore. And we use the significance level 5% or 0.05 to this problem.
Again, let's solve the problems using the chi-square test of homogeneity. And in processing our data, we will utilize Microsoft Excel to organize and compute statistics again. So assuming that we've got is a document containing all responses from the survey, of course, we cannot count each values one by one. So what we are going to do is calculate our descriptive, and this can also measure our population. So let's type sophomore and the freshman. And for the freshman, we have 40, while for the sophomore, we have 60. And our N, or which is the total, we have 100. So don't forget to add our border to better understand or comprehend the descriptive table. And the next step is we are going to create another table. We need to input the freshman and sophomore, which is the population or the groups. And after we input the freshman and sophomore, we need to input our study method like self-study, group study, or tutoring, and the total. And after we input the needed variables and categories, we need to write the value of each. Like for example, for the self-study, we have 15. For the group study, we have 15. And for the tutoring, we have 10. After we write all the values for freshmen, let's sum it all. Equal sum, then copy, and the result is 40. So the total of the freshman respondents is 40. So let's proceed to the sophomore. While the value of sophomore for the self-study is 25, while the group study is 20, and last the tutoring, the value is 15. So let's add this together and we have 60 total. So as we can see, the total of freshmen is 40 while the sophomore is 60. And let's add this together, we have 100%, and it is similar to our descriptives. The next thing that we need to do is let's add the value of each categories. Like for example, for the self-study, 15 plus 25, we have 40. And similar to the other categories, group study, we have 35. And for the tutoring, we have 25. So as usual, just like what we do, put a border again to make it look clean. So since we are done to our observed table, let's copy the table to create to create another table for our expected table. So change it into the expected and remove all of the values that we have in the table. So to get the expected value, the total of 40 in the freshman row will be converted into the percentage, like 0.4, and multiply it to the total column in the preferred study method, which is 40. And the result will be the expected value, which is 16. Like for example, 0.4 times 40 is equal to 16. So let's try to identify to the group study. So the total is 40, or what is the percentage of 40? 0.4 times 35 to the group study, we have 14. So for the tutoring, 0.4 times 25, 25 is the totality of tutoring. So we have 10. So we will do the same thing. So we will do the same process. So 60, the total of sophomore. So what is the percentage of 60? 0.60. And the total of self-study is 40. So 0.60 times 40 is equals to 24. And for the group study, we have 0.60 or 60 times 35, we have 21. And last, for our tutoring, we have 0.60 or 60 times 25. We have 15. The next thing that we need to do is add all of this together. For the freshman, 16, 14, 10 with a total of 40. Same to our descriptive and observed value. And for the expected, we have 24, 21, 15. We have 60. So after adding the column, we need to add each row. Like for example, in the self-study, 16 plus 24, we have 40. In our group study, we have 35. And in our tutoring, we have 25 with a total of 100. So let's get our chi-squared. So the formula of chi-squared is x squared or chi-squared equals to select the symbol of summation, and the formula is observed minus expected squared divided by expected. So let's follow the formula to get our chi-squared. So first we need to find our observed value. So our observed values is 15 minus expected value 16 and squared divided by expected again 16. So we have the total of 0.0625. And same process again, we need to find our observed 15 minus 14 squared divided by 14. So we have 0.0714 so on. So 10 observed minus expected 10 squared divided by 10 again, our expected. So we have 0. Same process. So 25 minus 24 to our expected squared divided by 24. We have 0.04166 so on. And our observed 20 minus our expected 21 squared and divided by 21. So we have 0.0476 and so on. For the last, observed minus expected squared divided by expected. So 15 minus 15 squared divided by 15, we have 0. So after we get all of this, we need to add all of the values that we got to get our chi-squared. So let's copy all of this equal sum. Now we have 0.22321426, and that's our chi-square. The next thing is we need to identify our DF or degrees of freedom. So we will follow the formula of degrees of freedom. Close open parenthesis, r minus 1, and close open parenthesis again, column minus 1. R means row, C means column. So we have 2 minus 1, close open parenthesis, and 3 minus 1. So 1 times 2 is equal to 2. So now our degrees of freedom is 2. So since we already got our chi-squared and our degrees of freedom, we need to write our alpha or our significance level. So our alpha or significance level is 5% or 0.05. And our critical value is 5.99. And we need to get our p-value. So to get our p-value, just type equal chi-square distribution and copy the chi-square value and the degree of freedom, which is the 2, and we have 0.89, so on. Since our chi-squared is less than 2 our critical value, we will not reject the null hypothesis. While for our p-value, since our p-value is greater than to our alpha or our significance level, we will accept the null hypothesis. And don't forget to add border to better understand and comprehend the table. So similar to what we did to our goodness of faith, let's do it to the test of homogeneity. Open the movie and find our documents. So let us open our documents file. What we can see here is the variables and of course the study method. Like what we did, we need to get our descriptive. Again, let's remove the components because we won't be using this. So for our variable is the students, and we would have to split it by the study method, and this should give us the total of 100. So after the descriptive, the next thing we need to do is go to the frequency table. So here we need to check the table to see how much the value appeared. So after checking the value of variables and categories, now let's have our bar plot for visualization on how those distribution can be presented, and that would be our descriptive. The next thing that we need to do is let's proceed to our frequencies. Click the frequencies and click the independent samples. After clicking the independent samples, put the students or group to the row, and we need to put our study method to the column. So after putting our variables and the categories, we have the contingency table, and these are the values calculated for chi-square independence. You may counter-check it through the manual computation, but this method are much more efficient. So since we already get our chi-square computation, next step is let's get our expected values. So here in the contingency table, we can see the expected and the observed value in the table. To get the expected value, the total of 40 in the freshman column will be converted into the percentage, which is 0.4, and multiply it by the total row in the preferred study methods, which is 40. So the result will be the expected value, which is 16. And let's get our bar plot for visualization on how those distribution can be presented. And now we can see our bar plot and the distribution. So now you can see the chi-square test. We have the same values as the one that what we got in Excel, and here using the Jamovi. The totality of the computation are similar to what we got in Excel.
Again, the significance level that we use is 5% or 0.05, and the values under our decision rule is x squared 0.2232 with the degrees of freedom equals to 2. So we can get our critical value using the significance level and the degree of freedom. So we get the result of 5.99, while our p-value is 0.894402. Now let's talk about our conclusion. So we can conclude that our critical value is greater than to our chi-square, so we will accept the null hypothesis. So since our p-value is greater than to the significance level, we will accept the null hypothesis too. Means there is a similarity between the study method of the students from both freshman and sophomore.
For references and citations, you may also scan this QR code to access our written report.